Hey guys, welcome back to AlgoYogi. We are gonna start binary search series now. I was thinking of starting dynamic programming, but it's actually taking a longer time than what I expected. So what I'm gonna do is I'm gonna continue recording binary search so that I'm able to post one video every day, but at the same time I'm recording dynamic programming, which would be about definitely 60-70 questions plus, definitely. So I'll keep doing that, and later I'll, after we are done doing binary search, I'll post them maybe as a series or like one by one. But for now, this is it. We're gonna start with the binary search very first problem, which is called binary search. So let's go to the problem on LeetCode. So given an array of integers, nums, which is sorted in ascending order. So this is very important when you are applying to, when you're gonna apply binary search, they need to be sorted. And an integer target, write a function to search target in the array nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with big of log n time complexity and run complexity. Alright, so you must write an algorithm with this runtime complexity, not the space complexity. I don't know, for some reason in my head it was like space complexity. But anyway, so let's understand actually what binary search is about. So now in a general scenario, like finding the target, finding this target, this is what we are trying to find in our array, which is target is 9 here, and this is our nums. We know it's present over here, but how we gonna look for it is the real question. So the very first brute force way would be just going element by element using a for loop and just checking if is this equal to our target. So let me write the indexes here. So 0, 1, 2, 3, 4, and 5. These are the indexes. Now we check at our index 1. Is this equal to our target? No. Is this equal to our target? Is this blah 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 blah? And then we come, yes, this is equal to target. Then we return 4. Okay, that would be our answer. But that's gonna take big of n time complexity, right? Now this is not what we want to return. We will return the right answer, but we want to attain the time complexity of big of log n. All right, this is what we want. This is what we are targeting. And we will using the binary search approach, and let's see how that will work. So what's really going to happen is, since the array elements are sorted in order, then we're going to use that property to check if can we basically bring down our search range. So right now we have this whole range. We have this entire range of array that we want to search one by one. But like, how about we use the property that this is sorted, this array is sorted, and we check basically some way, we're trying to utilize some property, some way that, like, let's cut down our input size. And that's what's going to happen using the binary search. So what we will do is, we have our basically left pointer, and then we have our right pointer. Now what we want to do is basically try to find the middle. So we will find the middle, basically left plus r divided by 2. That will give us our mid. Now we have the mid. So in this case, 5 plus 0 divided by 2 would give us 2. So this is what we come across as our middle. So this is our first middle, right? is this equals to 9? No, but that's one thing, that's one scenario like that's happening. We were kind of like trying to look like if it is equal to our answer, but this is not. So what we're going to do is basically if it is not, then we're going to compare it like, okay, are we going to find out, since we just divided our input array into two halves, so basically we divided into this half and then we divided into this half. This was our middle, which was not equal to our target. So what we're going to do is we're going to check if we're going to find our target in the array that's greater than my middle number that I just found out, or it's going to be shorter than my number that I just found out as my, on the mid index. So in this case, we can definitely tell that this 9 is greater than 3. Then we can basically now move our left pointer, which was initial, like right now it was pointing to 0. We can start pointing to basically our mid plus 1. So what can happen is my left can start pointing to mid plus 1. Now, if you see, my input is basically half. So earlier if it was n, now it's n by 2, all right? And now we're gonna basically do the same process again. We're gonna find the mid, which will be this time, right? 3 plus 5 divided by 2 gives us 4, and 4 is basically 9. And now we're gonna check if this is equal to 9. Yes, then we will return basically 4. I don't know why I have just written it, because it's hidden. So this will return basically 4. So return 4. This is our answer. But what's most important thing is this will basically find out our answer no matter wherever it is located. Maybe we were trying to search 0, then we would know that this time the element that we were looking for is smaller than my middle. When we found out the mid index for the first time, then we would know, then we need to reduce my right pointer by 1. So my right pointer would basically be mid minus 1. And that's how you keep, I'm sure, like if you guys are solving binary search, then you already know the basics, right? And it's all about getting through all these problems in our list on the AlgoYogi platform. And once you are done, you're done doing those problems, then you will know how easy it would get to basically solve other problems, other binary search problems. So now we know how to basically find our target and return our answer. Let's talk about the time complexity that will be big of log n. And how are we basically getting it? It all depends on this. Basically, when we are bringing down our input size each time to its half. So what's really happening is, each time we basically find out the middle and then try to basically decide which side we need to look our value into. So basically we are bringing down the input size basically half. So what's really going to happen is, first time we have our input basically of n size, and then from there we will know it's going to become n by 2, right? Because we just decide if we need to look at the the left side of the mid or the right side of the mid, and then it's going to keep happening. Later it will become n by 4 and then n by 8. So it's basically coming down as like each time it's just basically getting half. We're dividing it by basically 2 again and again. So divide by 2 reaches to n by 2, n by 4, n by 8, and maybe at one point the input size will basically become let's say it's 2 to the power this is, by the way, 2 to the power 3. If we want to write it in terms of 2 to the power exponent, so it's 2 to the power 3, and at one point it will become n by 2 to the power k, and that will reach at the input size 1, and that's when we basically, we are guaranteed, not really guaranteed, either we find our answer or we decide, just return -1 as the problem has asked us, that the target doesn't really exist. And so this becomes n equals to 2 to the power k. Now if you basically take log on both sides, so this k is basically the time complexity. If you truly ask me, this is what decides how many times we had to divide that input until we reach our target, or we don't find our target and return -1. So if we take logs both sides, by the way, base 2, so it will become log base 2n. So or we can write it the other way, so I think this is self-explanatory. So this is basically our time complexity, k, and to be honest, this is how it's going to be written. If you have studied logs, logarithmic calculations, then you would know. Well, I think now this is kind of self-explanatory why we have time complexity of big of log n. It's time to code it up, our solution. Okay, let's make it look a little nice. So as I said, we're gonna have a left pointer and the right pointer. So left and r 0, and then it's gonna be the length of our nums, and let's make it a little legit, so length -1. And now we're gonna keep bringing this window respectively to its half, and we decide which half to basically look into, and that's going to happen through finding the middle, checking if that's equal to our target. If it is not, then decide which side to go to. So we're going to have a while loop. So while left is less than or equal to right is just like the the 2 pointers approach, but here those 2 pointers decide these in the 2 pointers approach, our pointers were moving towards each other, but in this way we basically completely switch either of the pointers to the middle -1 or mid +1. Otherwise, if we don't find it, return -1, return -1. Okay, this is just for the final bit. But here, okay, most important thing is our mid. So let's find our mid. So usual scenario, mid we can find left plus right divided by 2. But remember this, in some languages, I think with Python it's okay, but in some languages this can overflow, because these values could be really large, and it could surpass 2 to the power 31 plus 1. I think 2 to the power 31 minus 1. If this surpasses that value, then it just causes like a memory leak or outage, you can say, and it will interpret something else only, like it would not be the value that we are trying to reach. So the better way of this is basically right minus left. So this will give us the difference, but then you want to add that to the left pointer. Okay, so I think this will give us our middle index. Right now these are pointing to the index. So okay, so let's check if my middle number, which would be nums mid, if this number is lesser than my target, that means what? My target is basically located in the bigger values, right? So this is not equal to my target, and my target is basically greater than my current pointer. So what I want to do is I want to move my left pointer to mid plus 1. All right, mid plus 1. If my target is basically smaller than this middle value that I just found, then let's say if this value is target is smaller, that means this value is greater than target. That means my target is, in the smaller values, a smaller set, half set, not like subset, but like half of the set, because we're breaking it each time. So now I will shift my right pointer to basically mid -1, right? And then final thing is like if none of these cases have matched, that means what must have happened is the value must have been equal. Only three things can happen. One is target is equal to your value, or target is greater than your value, or target is smaller than your value. Those two we have covered, greater or smaller. And then now is the final. Then we can just return our nums, not nums actually, we're returning the mid, we're returning the index. And finally, if nothing has happened and we reached to the to the last remaining index, in terms of we have made all the respectful right decisions, choosing to basically bring the left pointers ahead mid +1, or right pointers mid -1, and we couldn't find it, then we just return our -1. That means we didn't find our target. All right, so I would say let's run our code. Okay, it runs on the examples. Example cases are accepted. So let's try to submit it. All right, 100%. Well, it's a good solution, I would say. Okay, let's write the time complexity. This is kind of a ritual. The reason I do it is because it's usually asked, by the interviewers that, you just write down this. And it's a good thing also, just they want you to write it down so that they can save it as a proof that you have computed time and space complexity perfectly. Okay, so and then space complexity, by the way, like right now it's gonna be 1, since we're not really doing anything, so it's gonna be just constant space time complexity. And also remember that this thing that we have done, this can also be done recursively, right? Although it's kind of recursion, but like recursively I mean you could have a function being called depending on these calculations here, rather than we basically moving left pointer to mid +1 or right pointer mid -1. These will become parameters, and they will be sent as arguments, not parameters, arguments into the function, which will be search, and each time it will make a decision to search on a new subset. But here this is also equally good. इसमें भी कोई बुराई नहीं है. Alright, let's go to AlgoYogi, mark our problem solved, and see you guys later in the next problem. Until then, bye bye.